It's interesting, Mike. You mentioned the testing and structures being really designed to fail, right? Which is somewhat unique as an engineer in our industry. Kind of walk me through the desire to deal with the practicality of engineering and the conservativeness in engineering. That's kind of natural, right? I mean, you want it to just hold the load. And there's this pressure, somewhat pressure as an engineer, I can imagine, that you always want to pass the test, but just passing with flying colors is a problem too. So kind of walk me through that balance for you all as engineers where you're trying to get it right.
Yeah, there is a balance between the economies of a design, the efficiencies of the design, and the use and the cost, right? So you're always balancing that cost, and the first thing we do as engineers is we need to know what our lines are going to be subjected to for the next 100 years in terms of load. What kind of extreme winds, what kind of extreme loading are we talking about? And that's become already very complicated with climate change. All of a sudden, now we have a new variable to figure out, and how we can implement climate change and capture the effects of climate change, because the climate is not only heating, but it's also cooling. So the volatility between the heating and cooling cycles are much more, say, volatile than in the past, and how that affects the transmission line, which is placed over the landscape like a big net to collect all the storms. We have to understand that, and we have to know the impact of the any load differences so that we can incorporate them into design, and also do provide some kind of assurances to the public that we're actually looking at this, and we're actively looking at the impacts of climate change on our systems, the additional load, or in some cases the reduction in load due to climate change, and it's become a very big challenge.